Okay, this is another example of solving inequalities involving absolute values. And 4 plus 2 times 3x plus 1 is less than 30. So again, we want to isolate the absolute value. So again, you can think of this as an equation. 4 plus 2y is less than or equal to 30, or I should say an absolute value. And how would you solve this? Well, we want to remove the 4 first, and then the 2. So first of all, what I'll do is I'll subtract 4 from both sides. Kind of like what I did in the last problem. And now we have 4 minus 4 is 0. And again, remember, we can add or subtract the same number from both sides of an inequality and it doesn't change the direction, or we can multiply or divide by the same positive number. It's only when we multiply or divide by a negative number that we have to change the direction of the inequality. So now I've got 2 times the absolute value of 3x plus 1 is less than or equal to, and this is going to be 26. And then I'll divide both sides by 2. And since it's a positive 2, I can do that without changing the direction of the inequality, so that's a little bit easier. And now we have the absolute value of 3x plus 1 is less than or equal to 13. Now I have to remove this absolute value, so I have to decode it, so to speak. So I know that if it's less than, it's going to be an or. If it's greater than, it's going to be an and. And since I can't make that into an or, I remember that it's going to be an and, so I'm going to rewrite this as a conjunction. And. Okay, and you'll kind of see that how the conjunction works in just a moment. And remember, we could do this using the definition of the absolute value, but it is rather complicated, so it's just a little bit easier to remember this. So we write this down exactly the way it is. 3x plus 1 is less than or equal to 13. And then we write the inside of the absolute value, 3x plus 1 again, but then we reverse and negate, so this is going to be greater than or equal to negative 13. And then we just solve both of these. And since the left side is the same, we're going to do this, since both these are the same, we're going to do the same operations to isolate the x. So we'll subtract 1 from everything. And now we have 3x is greater than or equal to, and that's going to be negative 14. And 3x is less than or equal to 12. And I'm going to divide everything by 3. And I end up with x is greater than or equal to negative, and then 3 goes into 14 4 times, and 2 left over, so negative 4 2/3. And x is less than or equal to 4. Now there's a couple ways to do this when we want to graph the solution. Since it's a conjunction, we can write it as one inequality. X is less than or equal to 4, but greater than or equal to negative 4/3. So if you think about that, that means that x is between negative 4 2/3 and negative 4. Or you could graph it two ways, and it's an and, so you have to see both. So what we could do is we could say, if I find negative 2/3, if I find it over here, this is negative 4 2/3, excuse me, negative 4 2/3 right over here. Let me put a dot over here. This says x is greater than or equal to negative 4 2/3, so I could put and draw a line like this. And this is x is greater than or equal to negative 4 2/3. And this is x is less than or equal to 4, so I could put a dot over here. And that's x is less than or equal to 4. And then on my number line, since it's an and, it's going to be where I see this and this, or both lines, two lines. have got to be true. So this and this. So that would be in here. This is where I see two lines. That means both things are happening at the same thing. That's what a conjunction is, a little more powerful. You have to have both things happening. And like I said, another way to write it is, since this is less than 4, you can just write x is less than or equal to 4, and x is, see it's pointing to, greater than or equal to negative 4 2/3. So you could also write it like that. You can do that with a conjunction, not a disjunction, but with a conjunction. You can do that with the and, not with the or. Okay? And then if we want to use interval notation, then again, since it's equal to, we have a dot. I should have mentioned that. Since it's less than or equal to, or greater than or equal to, less than or equal to, we have a dot. Greater than or equal to, dot. Less than or equal to, dot. And then if we're going to do interval notation, those would be brackets. So that's going to be bracket. And that's going to be from negative 4 2/3 to 4 with a bracket. And you don't always have to write it as a mixed number. We just did this so it'd be easy to see on our number line. So you could also write it like this. Negative 14/3 and 4. And those are brackets because we have the less than or equal to. Okay? So if that makes sense. And again, you can follow the work, and some of the easier problems, this will kind of match up. So the tricky part is deciding whether you're going to use an or an and. And then once you do that, you break it up into two easier problems. The and is called a conjunction. Guess I should note that. And the or is called a disjunction. This is the disjunction, and the and is a conjunction. Okay.